And this is a quick review of factoring. So quick review of factoring. I can't emphasize enough how important it is for you to always think to factor out common factors first. And no matter what you're factoring, trinomials, binomials, whatever, you always have to look for common factors to factor out first. And I just had a quiz in Algebra 2 and numbers of students, even though I've been emphasizing this all through Algebra 1, all through Algebra 2, they still forget to factor out common factors first. And the reason why is because there aren't always common factors. So they'll go through a few problems without a common factor, and then they forget to factor them out. All right, here's our first example. So you look at this, you got a binomial. Well, I'm looking for common factors. Okay, so I see a common 5. 5 is common to 45 and 20, which, by the way, would leave me a 9 and a 4. I see a common z. All right, what's left then? What's left is an x squared, a minus, and a y squared. Okay, so I factored out the common 5z. And again, why do people forget to factor out common factors first? Because not every trinomial binomial has them. But you always have to look. All right, now I have to look at what's left. Now remember, binomials, if I'm going to factor them, basically it's difference of two squares or nothing. Well, this is a difference of two squares. All right, remember the pattern? Two parentheses, plus in the middle of one, minus in the middle of the other. The square root of the first term goes first. That's a 3x, right? The square root of the back term goes in the back. That's a 2y. All right. So we get 3x plus 2y, 3x minus 2y. Final answer, 5z times the quantity 3x plus 2y times the quantity 3x minus 5y. All right, and then don't forget trinomials. So I'm looking for common factors. Guess what? On this one, there are none. So I know I'm going to need two parentheses. But here's the thing. The front term has two possibilities. So I'm going to set up two possibilities. I'm either going to go 6x and x or 3x and 2x. Now don't forget, in the midst, we're going to use a negative 10 in the back, right? We're going to use factors of negative 10, but it's all about the outers and the inners equaling a positive 7x. So again, I'm going to start thinking through some possibilities. And again, this is how I think. If I stick a positive 10 here, I've got 60. That's way too much. That's not going to work. I'm not even going to do that one. It's stupid. If I stick a 1 here, I got a 6, but then a 10 in here. Is a 6 and a 10 ever going to equal 7? No. So, 1 and 10, not going to work. How about 2 and 5, though? If I put a 2 here, I've got a 12. And a 5 here, I got a 5. Wait, 12 and 5 can add up to 7, especially when the 12s are positive and the 5s are negative. Doesn't that give me a 7x in the middle? It does, and guess what? There's the factoring of that. I don't need those. It wasn't the 3x and 2x, it was the 6x and x. All right, factoring. Be careful. You should know how to factor out common factors. You should know how to factor a difference two squares, and you should know how to factor trinomials.